Hi everyone. So today's SAT kind of review topic, I'm going to be talking about the equivalent forms of a quadratic equation. These standardized tests want to really get you to understand that there is a difference between what solving an equation means and what an equivalent form of an equation is. They want to make sure that you understand how to go backwards and forwards between them. So let's remember quadratic equations are equations in which the highest exponent of your x is a square. So our first one we're going to look at is standard form. So y equals ax squared plus bx plus c. So standard form equation is one that we often find. A couple things that I want you to know about standard form. Standard form, we know that our y-intercept would be 0, c. Okay, so we can see the y-intercept just by looking at it, okay? If I want to find the vertex of a standard form equation, I can do x equals negative b over 2a, and then I can plug in x to find y. Okay, so that's vertex, that's y-intercept. And if I wanted to find the x-intercepts, I can set y equal to 0 and solve, either by factoring, completing the square, or using the quadratic formula. So that's going to give me the x-intercepts. And obviously, I'm hoping at this point, if you're watching this, you have finished Algebra 2 and you know that the graph is actually a parabola. Could open up. It also could open, what we would say, open down. All right, so that's standard form. So again, you can see the y-intercept as a constant in the equation. You can find the vertex by doing x equals negative b over 2a and then plugging in the x to find your y. And then you can find the x-intercepts by setting y equal to 0 and solving using one of the methods to solve a quadratic. But then we have vertex form. So vertex form is a little bit different. Vertex form is y equals, let me switch colors there, y equals x minus h squared plus k. And yeah, I could have an a in front of here too. A's, if it's positive or negative, a will tell me whether or not the graph opens up if a is positive, and if a is negative, then it's going to open down. Now, A will also tell you, actually the absolute value of A will tell me if it is a vertical stretch or shrink. And you probably learned those terms, so stretch or shrink. You learned those terms in Algebra 2 as well. So stretch is going to make it longer and narrower, so this would be a stretch closer to the y-axis, whereas shrink would be getting farther away from the y-axis, so a little bit wider. What's really, really nice about vertex form is you can see the vertex as constants in the equation. Remember, constant's just a number. So my vertex is going to be hk. All right, so if I gave you y equals 2x minus 5 squared plus 3, then yes, I can see the constants 5 and 3 as my vertex. Now, to get the y-intercept, though, it's a little bit different, remember. So if I want to find the y-intercept in vertex form, I have to set x equal to 0 and solve for y. The y-intercept is not k, like the other equation. Remember, hk is your vertex. And then to find the x-intercepts, we set y equal to 0 and solve. And usually the easiest way, if it's in vertex form, is to use the square root method. Meaning isolate your square and then take the square root of both sides. So I'm not going to go through that in this video. I just wanted to talk about the equivalent forms of a quadratic. All right, and then the last one is intercept form. That's the mathy name. I like to think of it as factored form, okay? It's in factored form. So y equals a, x minus p, x minus q. Okay, so this form, we can actually see the x-intercepts as constants in the equation. The x-intercepts would be p and q. And remember, x-intercepts would be then p comma 0 and q comma 0 because those intercepts are coordinate points. Now, if I wanted to find the vertex, there's a couple ways I could do that. I want to remind you that the vertex, the x-coordinate, has to be directly in the middle of the x-intercepts. So to find the x-coordinate, you could just do the average of the intercepts. Average of the intercepts. And then to find the y, you'd plug in x. So just keep that in mind because remember that parabola has symmetry right down the vertex. So let's pretend for a second these are the x-intercepts. If there's symmetry, that means that they have to be the same distance to both sides, which would make that point the midpoint, which we find the midpoint by finding the average. All right, so these are the three equivalent forms. Standard form, ax squared plus bx plus c. I can see the y-intercept as a constant. Vertex form, y equals a, x minus h squared plus k. I can see the vertex as a constant. And then intercept form, y equals a, x minus p, x minus q, where I can see the x-intercepts as constants in the equations. All right, so let me show you some examples of how you might see it on the SAT. Here they gave us, and this is considered a hard problem. It says, which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation? So they gave me a standard form equation, and they want me to give you, they want it in vertex form. Now, that doesn't mean you have to put it in vertex form. That means that you just have to be able to identify which one is vertex form. So look at these equations. Here, let me write this one down. So it was y equals x squared minus 2x minus 15. So I know my graph's a parabola, and I know I'm given it in standard form. So in looking at this one, A is actually factored form. That's not going to give me the vertex as constants in the equation. B is also in factored form, so that's not going to give me the vertex and constants of the equations. Now, we have to look very carefully. C is actually kind of tricky because it looks kind of like vertex form, but I don't see a square there. And if I distributed this, it's going to actually give me the standard form equation. So it's not C either. So D could actually be my only option. Is it in the form y equals a, x minus h squared plus k? Well, it is, and is that the vertex? So look, my vertex is right here, a little bit below 15, so my vertex is 1, negative 16. So look, my vertex here as constants in the equation is 1, negative 16, so my answer would be D. Not so hard, but it's actually question number 30, so it's considered a harder question. All right, let's look at this one. The equation above represents a parabola in the xy plane. So this time they didn't give us a graph. Which of the following equivalent forms, there's that word again, equivalent forms of the equation displays the x-intercepts of the parabola as constants or coefficients? So it's asking me for the x-intercepts, so that means the equivalent form would be factored form. Factored form. So what would I do? Well, I would factor this. So I'm looking for the factors of 8, things that multiply to a positive 8 that add to a negative 6. So that would give me y equals, that would be 4 and 2, and they would both need to be negative. So x minus 2, x minus 4. And I look at these equations, really the only one in factored form. I would have eliminated those because those aren't factored form. D is the only one in factored form, and when I factored it, that is exactly what I got. So remember, we are looking, when it asks for you for constants in the equation, the equivalent form, you have to think of one of those three forms. All right, guys, hopefully that was helpful. Have a great day.